Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to explore the concept of host volume integration in Docker application. Okay, so first we are going to explore what is this concept, how we can implement this and why we need this, and then we will be exploring how we can utilize this particular feature of Docker in building AWS Lambda Layer for our real world projects. Okay, so let's start with what is host volume and how we can implement that. So in any Docker application, the general flow is first we write the code for a Docker file and then we build it, and it basically results into creation of a Docker image. Once the Docker image is built, either maybe we can push this particular image to some Docker repository, for example AWS ECR or Docker Hub, and whenever needed we can pull it, and then once the image we get, we basically apply docker run command to create container out of it. And container is nothing but within a virtual environment, within a isolated cluster kind of thing you can consider, where our code runs after installing all the dependencies from Docker image. So in general we can say, if this is our host machine, within here if we basically run our Docker image, here our container will start. And in a typical flow of Docker file looks like this, that first we consider a base image, for example Python 3.8, and we copy all the files from our current host directory to the app folder within our Docker image, and then we create that app folder as working directory, we install all the requirements module, and we run our Python application or a particular command, whatever we want to execute. So starting from here to here, this particular part gets executed when Docker image is built, and this last line command python app.py, this gets executed when we run our Docker image. Basically when the Docker container starts, that time it executes this particular command. So this is a generic idea what we gathered in our previous video while exploring the fundamental concept of Docker. Now let's try to understand one particular problem with this project. So here suppose we are having in our host machine somewhere app.py. This app.py we are copying to our Docker image using this particular line, and then we are building the image, and when we are running that image, the container is launched and it is basically running app.py in that container runtime. But suppose we have made now some changes in this app.py. Then if we run our container directly, it will run with old code only, because while creating the Docker image, that time itself the code was copied. Now the new copy will not happen. So what we generally need to do, we need to again create a Docker image so that this particular line will be executed again, and the latest app.py will be copied from our host machine to our Docker image. And then if we launch a container using docker run command using that latest created image, that time it will basically execute the latest updated code. So what I am trying to say, if you are building a Docker application in the development phase, again and again there is a possibility that the app.py or our main code will be keep on getting changed, and that many times we need to create Docker image just to run that updated code within our Docker application, and this might be a time consuming process. So can we follow some pattern where our app.py we can change as many times as required, and whenever we will run our Docker container, it will take that latest code from the host machine instead of already copied old file while the Docker image we were building, and the container will execute that latest app.py from the host machine. So that way again and again whenever app.py will be changed, we no need to build Docker image. That's the ultimate goal. So I hope the problem statement is clear to you. So here I can write or draw the diagram in a simpler format. So the ultimate requirements look like this, that here suppose we are having our app.py, and here we are having our Docker image. Now is there any way that from this image, when we will be launching a container, the container will always refer the latest app.py, no matter whether the image when it was building, whether it considered latest app.py or not. So that particular problem can be solved using host volume mounting. So what is that? Basically what we will do, using a particular feature of Docker, we will point the container run to the app.py whatever is available in our host machine instead of whatever is available in our Docker image. Okay. So whenever container will run, that time it will take the latest code from the host machine. So that is nothing but called host volume mounting, because here container is basically a separate virtual machine kind of thing we can consider. It will basically refer the code which is available within our host. So that is nothing but called host volume mounting in Docker. Okay. So in certain situations, such as when developing a new containerized application, we might need to consume data from certain folder from host. And I hope why we need that is clear to you. And that time we can basically mount the host volume in our Docker application and use that. So now let's try to explore how we can do that. So for that, first what we need to do, we need to install Docker, and then we will follow the generic pattern. I will show you that whenever app.py we will change in our host machine, that time again and again we need to build Docker image if we follow the normal pattern, and then we will explore how to resolve this particular issue using host volume mounting. Right? So without any further delay, let's start with launching an EC2 machine where we'll install Docker. So here I will go to my AWS management console and I'll click on launch instance, and here I can give the cluster name as Docker YT host machine demo. Okay. The Linux environment I'll be choosing this particular free tier 1. T2 micro is fine because we are just doing for POC purpose. The key pair I'll be choosing one existing key pair, and without any other changes I will launch my instance. So it is going to take few seconds. Let's wait for that. Once the instance will be up and running, we will basically install Docker image. So here you can see it is in pending state. Let's refresh, and here our instance is in running state now. I will basically use putty to do SSH in it. I will take the key pair file, whatever we have configured, and I'll open this and login as default login ID for Linux machine is EC2 user, so I will use that only, and I'll change this setting to avoid timeout, so I'll make this 10 seconds. Now here what we'll do, we will install Docker first. So here this is the first comment where we are updating if anything is not updated. Now here we are launching Linux Docker. So let's wait for some time. It is going to take some time to install all the required dependencies. And here it is done. So once Docker gets installed, we will start the service. And then here we need to give some proper permission, and I need to restart this particular session. So I will close that putty session and re-log in. Login as default login ID is EC2 user, right? So now Docker is installed. If you want, you can just execute docker info, you will get all these details, right? So that is done. Now let's build a typical application. So here I will be creating a directory called hello world, and I will go inside that particular directory. Okay, I will clear all this, right? We are now in hello world directory. Now I will be creating a Docker file. Okay, typical Docker file what we created in our previous video as well. And I'll go to insert mode. I'll be copying this particular code base. Right, that is done. Now here, this is our app.py. It is doing a very simple job. It is basically making a request to this particular API endpoint to get the current Bitcoin price. That's it. Okay. So vi app.py I will do. I'll go to insert mode, and then here I will paste this. So app.py is created, and last but not least, we need requirements.txt. Obviously, request module URL are related, and py reset for timing. So here I will basically create that particular file as well. Okay, right? So if I now do ls app.py docker file requirements.txt, all three are available. Now what we'll do, we'll build a Docker image out of it. So here docker build -t welcome app dot. So using this in the current working directory, whatever Docker file is available, based on that the base image will be pulled, the pip install will happen, and our image will be ready. So once that is done, if needed, we can execute docker image ls to check whether our image got created or not. So let's wait for some time till it get created. So here it is done. Now I can do docker image ls, and here you can see welcome app. This particular image got created, right? Now if we want to run a container from that image, all we need to do docker run, and then we need to give the image name. So here the image name we have given welcome app, so that same name I'll be basically using here. And I'll hit an enter, and here you will see it has basically printed the current Bitcoin price and other information, whatever it got as part of response from that post request or get request, whatever we have done. So here we have done get request actually. So here if you see, print the extracted data is, and here we are printing the JSON whatever we achieved, and that same thing is displayed here. So that means here our docker command is perfectly working as per expectation. Now let's see, suppose we are making some changes in this particular app.py, okay, and that changes will be obviously doing in our host machine, right? So that change is nothing, a very simple change. We are adding an extra UUID key in our data, and that will basically take string of UUID4. One unique ID we are adding, which is not available currently in this particular data. As you can see, the last key is timestamp. All we are doing is adding an UUID field, right? So these changes I'll be doing in my app.py. So here again I will do a clear, and then what I need to do, like generally if we just perform rm app.py and then here vi app.py, and then here I can paste this particular updated code, and I can do :wq. Okay, so here if you see in our latest app.py, so I can do get app.py. Here you will see that this particular UUID field is added. But now if I run our docker container, let's see what will happen. So again same command docker run welcome app I'll be executing, and if I run, here you will see that the UUID field is not coming. Why it is not coming? Because here if you see our docker file code, initially when first time we were building the image, all the files from our current working directory was copied to the docker app folder. So that particular image was built based on the older version of app.py, which still available within that particular image, and docker container is using that old app.py only when executing this particular CL. That's the problem. That's why although in our host machine the code was updated, but the container is running still with that old code. So obviously I hope you can understand now that in the development process it is a very difficult task if I need to again create that particular image. So in this case, to get the updated code, I need to again build that image so that it will consider the latest app.py from the host machine. It will copy to that docker, and then if we run docker run app.py or docker run welcome app, that time here you will see that UUID field is coming. So in development time, again and again in our app.py there is a possibility of code change. So that many times building an image just to run the docker container or our application within docker, it is a very tedious process and obviously time consuming process too. Now to solve this, what we can do, we can run our docker container such that it will point app.py to our host machine folder, and it will consider the latest code. So try to understand what I am saying, that when we are building the image, let the code be as it is. Let the app.py from the host machine get copied within our docker, whatever code is available. Now when the container will run, it is only running this particular code. All I want docker to take the latest code from the host machine instead of taking the already copied file within the image. So that I need to make sure that this command is taking the app.py from the host machine. So for that, we need to mount the host machine volume or host machine storage to the docker, and that we can do using this particular command. Okay, let me explain what is that. So here I no need this particular thing. Earlier to run the container we were using docker run welcome app. Now let's see what are the changes we have made there. All we have done, we have added a extra line -v pwd:/f. So what this is saying? This is saying that when the container will run, the app folder which is available within Docker container and our host machine current working directory should be linked. So if there is any code available in host machine, that will be accessible from the app folder within Docker container, and if any code changes are done from within the Docker container app folder, then that will be reflected in our host machine current working directory as well. So both way communication should be possible. So if we mount this way the host storage to the app folder, what will happen? Both way communication will be possible, and when the container will run, it will not consider the already copied file when the image was built, but rather while executing this code, it will take the latest app.py from the host machine where we are doing the development. So that's the hint. So here I can run with this particular command. So I'll clear this, and if I run docker run app.py with this host volume mounting, we will get the same code. Now let's see whether it is really working or not. I will make some changes in our app.py. So vi app.py I will go to insert mode, and here I can change the print statement, the expected data after host volume mount. Like that way I added a modification in the print statement. Okay, and I will write and quit. Now I will not build a new image again to reflect the latest codes within the container. All I will do, I will run this particular command, and that time what will happen? Although we are saying that the container should run app.py, but it will not consider that app.py which was already copied when the image was built, but it will consider that particular app.py which is available in our host machine current working directory. And this app.py, whatever we have modified, that is in our host machine, in our host EC2 only, right? In current working directory. So from there, it will consider that particular app.py and run it. So here if you see, now it is showing the latest changes, that extracted data after host volume mount. So this particular thing was not available when the image build was happening. This we did after image build, but still the Docker container able to consume the latest code and execute accordingly. So using this particular simple example, we able to understand one thing, that if we make some changes in our host machine and if we run our Docker container like this way, then the container will take the latest code from host. Okay, so from host to container, the communication is happening. Now let's see, within our container, we will make some changes. Whether that will be reflected in host machine or not, that we are going to explore now. So what I will do for that, here I am going to modify this particular Docker file little bit. So what I will do, instead of this particular command, let's consider within our container, I'll be creating a new file. So maybe I can use touch command, touch test file.txt, like that. These requirements.txt no longer needed here. So this is our updated Docker file. So within our container, we will be creating a test file.txt. Obviously that is an empty file. And if we mount our current host directory with the app folder within our container, and from container when we will be creating a new file, let's see whether in the host machine we will able to access that or not. Okay, so I will update our Docker file. So vi Docker file, and here I will delete the existing code and I will put the latest code. Colon wq, our latest Docker file got created. Let's do first ls. So ls we have done app.py Docker file requirements.txt. You can see here in our host machine currently these informations are available. And now we will build the Docker image, because the Docker file itself got changed. So Docker image I need to create once so that it will consume the latest code. And here the build is done. Now let's execute that container code again. Okay. So docker run -v pwd app welcome app. So let's see, it is done. So what we have done, within container we have created this particular file. So ideally, because the host current working directory and container app folder are mounted, so if I just now do ls in the host machine, here you will see test_file.txt, this empty file got created. That way I hope you are getting this concept, that if you mount your host directory with the app folder in our container or whatever directory within the container, whatever changes you make in the host will be reflecting in container, and whatever changes you are making in the container, that will be reflecting in the host. This is a very vital concept. I hope you understood this. Now we will try to explore that how we can utilize this feature of Docker in building Lambda layer very easily. Stay tuned. So now we are going to explore how we can utilize the concept of host volume mounting in Docker container for streamlining the Lambda layer build process. So let us have a quick recall on Lambda layer. Suppose here you are having a Lambda function with Python 3.12 execution environment, and you might be requiring some external Python module which by default is not available in Lambda execution environment. For example, pandas, right? Then NumPy, or maybe request module, etc, etc. So that time what we do, we perform a pip install for all these modules in a specific folder, and then we zip that particular folder and we create a Lambda layer, and that Lambda layer we attach with our Lambda execution environment or Lambda function. That way we can use all these external modules in our Lambda code, and this particular pip install, all these external modules should be happening in a particular folder structure. For example, if you want to create the Lambda layer for the version 3.12, then within Python, within lib, within Python 3.12, within site packages, we should be having all the pip install. Suppose I want to create a Lambda layer for the Python runtime 3.8, then Python lib site packages will be same. Only here instead of Python 3.12, here we should be having Python 3.8 as the folder name. Like that way, if we arrange the folder structure and within site packages, we can do all the pip install, and then if we zip them and create a Lambda layer, and if we attach that with our Lambda function, then all these external modules will be accessible. Now generally what we do, suppose here we are having a host machine that can be Mac OS, Windows or Linux, whatever machine we are having. I am considering generic way as host machine. In this machine, we want to create that zip file for our Lambda function. Okay. Now in this host machine, suppose Python 3.8 is installed, and the Lambda function for which you want to create the Lambda layer, suppose that is 3.12. Okay. Now in this 3.8 runtime environment, if you follow this proper folder structure of 3.12 and zip properly and create the Lambda layer properly, still there is a possibility that the module after adding the Lambda layer also may not work properly in this Lambda function. And the main reason is, in our host machine we are having 3.8 as runtime, and in our Lambda function the execution environment is 3.12. So it is always better to create a Lambda layer in such host machine which is having same Python or runtime what our Lambda function is having. But in general, it is very difficult to have multiple Python installed on same host machine just to create different Lambda layers for different Python environment. For example, I might be having the Lambda function from 3.12, 3.11, 3.9, 3.7 and whatnot. Now for all these different Python version, it is very difficult to install all these version in host machine just to create Lambda layer. So instead of doing this way, what we can do, we can take help of Docker. We can basically create an image where that particular Python version will be installed for which I want to build the Lambda layer. For example, if I want to build the Lambda layer for Python 3.12, I'll be creating a Docker image where Python 3.12 will be there. If I want to create a Lambda layer for the Python runtime 3.11, I'll be taking such Docker image where 3.11 will be installed. Then within that Docker image, we'll be creating this particular folder structure and we will do pip install. Okay, that way the pip install where it is happening within Docker container, right? And the Docker is having same Python version what our Lambda function is having. So that way if we build a layer from within the Docker, then we will have no problem in our Lambda function when we will attach that particular layer. So here what we will do, we will be taking a Docker base image which is having that particular Python installed for which the Lambda layer I want to create. That is step 1. And as part of step 2, we will do that pip install, we will zip, and then this zip file will be available within our Docker container. But the Lambda layer we may be creating from host machine, because that host machine, suppose that is EC2. The EC2 may be having certain role using which we can create a Lambda layer. So it will be better if we can get this particular zip file outside the Docker container in the host machine. That is, we will create the zip file within the container, but once it is created, it should be accessible from the host also, so that from host we can create the Lambda layer, or we can use that particular zip file for other purpose. Okay, so that way the only purpose of using Docker will be to have same runtime what our Lambda is having. Now once the zip file is created, we can take that in our host machine, no longer the container is needed, and then we can basically execute AWS Lambda create layer something, this kind of shell command from our host machine to register that particular layer in our AWS Lambda service. So I hope now you are getting that how the host volume mounting will be helping us, because here the zip file what we are creating within container, but once it is created, it should be available in the host. So what we will do, that host directory and the container working directory will be mounting. So that way, whatever file the container will generate, that will be available in our host machine also. Like in our earlier section we have seen, when we created a particular file with this touch command, although we created within container, but because we mounted the host current working directory and Docker working directory, so this test file.txt was accessible outside the container also. That was available in host machine also. So this way we can streamline the Lambda layer creation process. First, we will basically pull the base image which is having that particular Python version what our Lambda is having. We will follow the proper folder structure and we will install all the required dependencies using pip install command. We will create the zip file, and because of mounting with respect to host and Docker container, that particular zip file will be accessible outside our container also in our host machine itself. And then we can use that particular zip file to create Lambda layer, and we can attach to our Lambda function to use it. So that's what we are going to do now. So here let me clear all this. So here this is the code what we are going to follow. So as a first step, what we need to do, let me create a folder within our host machine, mkdir layer, and here I will basically go to that particular layer. And then here I need to create a requirements.txt file where I'll be putting all the external Python modules what I want to use in our Lambda function. That is, for them we want to create the Lambda layer. And suppose those are pandas, numpy and request module. Okay. So now here what I will do, colon write quit. And here our requirements.txt file is created. Now what we will do, we will launch a Docker container which will be having that same Python runtime for which we are creating the Lambda layer. Okay. So let's consider we are having a Lambda function. Let me just quickly create a Lambda function of Python 3.12 runtime environment. So here I'll go to Lambda, create function name demo yt Docker layer build, something like that I have given. The runtime I can choose Python 3.12 and I'll create the function. Okay. So here our Lambda function is created, and now let's consider I need to import pandas, numpy and request module, all these three things for a particular workload. Okay. So here I can write import pandas as pd, import numpy as np, and import requests. Okay. And here I will deploy this particular function, and here if I click on test and run the test, here you will see that the job is failing and it will basically return that unable to import module pandas, because pandas module is not available by default in our this particular Python runtime Lambda function. Okay. So what we need to do, we need to create a Lambda layer which is compatible to Python 3.12. So for this particular purpose, we will be using this particular command. So what it is saying, so number one, as I told you, the base image should be having that particular Python, what version you are using in your Lambda function. So I am pulling such base image, that is public ECR AWS/sam/build Python 3.12. If you pull an image of this particular name, here whatever container will be created, there the Python version whatever will be installed, that is Python 3.12. If you want for Python 3.8, just write Python 3.8. If you want Python 3.9, just write that one. Okay. So here I want for Python 3.12, so I am using that. Okay. And then here Docker run. So generally whenever we create a Docker container, first we create a Docker file, then we build an image, and in that image also we are having some base image, and then we do some more installation, and as per that our original image get created, and from there we create the container. For example, a sample code can be shown like this way. Here this is the base image, and these commands we write in Docker file. From here whatever image get created, that when we run, that create the container. But you can run the container in another way also, that is in a single line. For example, docker run, and then here I am giving this particular image name. So it will consider that this is a base image. So basically this particular line here, whatever we have written, that same thing is depicted here, that I should consider this as base image. Then here I am defining working directory /app. That you can mention inline like this way, -w/app. So this will consider that I have to install the base image, or I have to pull this particular base image, then I have to consider working directory as /app. Okay. Then docker run is basically for running this particular container, right? So this is our base image, that when I will run, that will be a container. So docker run I am using. And then here this is volume mount. So what I am doing here, I am basically mounting my current working directory from host with our container /app or container working directory. So that within this particular container working directory, once we will do pip install and then we will create the zip file out of it, that zip file should be accessible in host current working directory as well. So this is nothing but that volume mounting concept, whatever we discussed just now. So I hope from this part to this part is clear to you. Now here rm command I am using. So what it is basically saying, that once the container job is done, or once the container exits, then delete the container. So for that purpose we use -rm command. Otherwise the container stays in our environment and the environment may become messy. So once the container job is done, just delete it. So for that purpose rm I am using. And one more thing I need to do, that is -it bin bash. This one I am using. This will give me a interactive terminal within Docker container where I can execute the pip install command, that zip file command and all these things. Okay. If I don't use this bin bash, then directly the container will be launched and it will not allow me to enter some shell script within the container, and that way our job will not be fulfilled. But here what we want to open a container which is having that particular Python version installed, and in that container I will do some pip install requirements.txt in this particular folder structure. And because of this volume mounting, although we are doing installation within the container, but it should be available in our current working directory as well. So I hope the point you got it, that this is the command we have to use. Bin bash and -it is used to give me interactive shell within the Docker container, right? So I will execute this particular command now. And here you can see as a first step what it is doing. It is pulling this particular base image, and then here it will give me an interactive terminal where I can execute any commands within this particular Docker container. And because we have done volume mounting, so in the app folder whatever new file will be creating, that will be available in current working directory as well in our host machine. So let me show you that as well. So for this purpose I will open another terminal, and if I do ls, here we are having layer, so cd layer I will do, and if I do ls, currently only requirements.txt is available in our host. So let the container get ready, and here once all the Docker image pool will be complete, it will give me a bin bash shell, like here you can see, right? So now here what I can do, I can install the requirements.txt. Now here see, this particular requirements.txt is not available in our Docker container. We have not copied while launching the container, right? But still it will be accessible. Why? If you ask, it is very simple due to this volume mounting. Because the requirements.txt, this particular file is available in our current host machine working directory. And the working directory we have mounted with app folder. And currently we are in the app folder within our container, right? If you do pwd within our Docker container, here you will see app folder. So app folder will able to access the host machine's files also. So here you see that although requirements.txt we have not pulled, but because the volume mounting happened, so requirements.txt here we are getting. So now we can simply do pip install requirements.txt, and we can follow this particular format what we generally need to follow for Lambda Layer build, right? So let me just show you. Till now in our this particular host machine only requirements.txt is available, and this is host machine, not our layer. Now what I will do, I will just execute this particular command within our Docker container. Okay. So here it is installing all the required things, and once it will be installed, I will basically execute this command within container only. right? So here you see that we are basically doing a pip install in this particular folder structure, that is Python lib Python 3.12 site package. And these folders will be created in the app directory within container. And because app directory is linked with our current host working directory, so if I do ls, here you will see the Python folder also got created in our host. If I do cd python and then do ls, here you will see lib, because here in the container we are creating this folder Python lib Python 3.12 site packages and so on, right? Now once that installation is complete, I just need to do zip r pandas numpy, I can give requests also, right? Zip and start everything whatever is available in our current working directory within the container, that I want to zip. Okay, so just to show you, here till now I am in my current working directory only, that is /app within the container. And if I just do ls, here Python and requirements.txt is available, same thing was available in host. And what I will do, I am saying that I want to zip everything whatever is available here, and I want to give that zip file name as pandas numpy request.zip. Okay, so let's execute that. It will create that particular zip file. So here zip file is created. Now if I do ls within our container, here you will see one zip file is also available. Okay, and this zip file is created by installing all those external Python dependencies, keeping this concept in mind that the container is having same Python runtime what Lambda we want to launch. For example, here if I write Python 3 -- version, here you will see Python 3.12, because here the Docker image whatever we have taken as base image, they are Python 3.12 was there, right? And because of this volume mount, what will happen in our host machine also, if I do if I go to my host, that is in layers, now if I do ls, here you will see pandas numpy request.zip, this particular zip file is available. If we would not have done that volume mounting with host, we will not able to get this particular zip file here also. It will be only accessible within the container. But here also we are getting. Now the next step will be very simple. We can create a Lambda layer, right? So to create a Lambda layer, what I need to do, I need to configure a role for our EC2 so that EC2 can create the Lambda layer. So here I will go to my instance, and here I will go to action, and security section I will go modify IAM role and create a new IAM role I will use, and here I will click on create role, and this time I want to create a role for our EC2 machine so that it can publish a new Lambda layer. Okay, so for the time being I can provide AWS Lambda full access, Docker layer deploy demo name I can give, and I'll create the layer. So the layer is created, and here I will attach that particular policy. Sorry, it was a policy. That policy I will add in our EC2 so that EC2 can publish a Lambda layer in this particular US East 1. Okay. Now here what I will do, I will go to my host machine. I am no longer in container in this terminal, and here I will do AWS configure. Okay. And here access key I no need, secret key I no need, only region I will mention US East 1, and then I will hit an enter. So that way it will make sure that whatever Lambda command from terminal it will be executing to register that layer, it will be in US East 1 only. Okay. Now here I will use that Lambda layer create command. So the command is like this: AWS Lambda publish layer version, layer name we can provide Python numpy requests from Docker, compatible runtime Python 3.12, and our zip file is this particular one. What is the name we have given for our zip file, that we need to provide. Okay, and this is the name. So let's run it from our host machine, and here you can see we are getting the response that it is successfully registered. So here if I go and refresh our layer, here you will see pandas numpy request from Docker, this particular layer got created. Now here I can add this particular layer in our Lambda, that is basically this particular one. The version, as of now only one version is there, I'll add it, and Lambda layer is added. I can go to the test and I can run test. Okay, so here you can see this time it got succeeded. Although we are importing pandas, numpy requests which are not available by default in this Lambda runtime, but because of this particular layer creation, it was possible, right? So I hope you understood this, that using the volume mount command, we can easily streamline the process of Lambda layer build, and obviously it is solving that particular problem, that if your host machine is having one particular Python version and the Lambda layer for what Python runtime you want to create, if that is different Python version, still we will have no problem, because here we can easily consider any base image which is having same Python version as of our Lambda execution environment, and there we can mount the volume, we can open bin bash shell as a interactive terminal, we can execute all our commands, and because all these things are attached to our host volume, so this particular zip file will be also available in our host machine, and then we can basically execute the AWS Lambda command from our host machine itself to register a new Lambda version. Okay, and now let me show you another interesting point related to Docker RM. So here if you see in this particular terminal, we are in our container, within our container, right? And in this particular terminal, we have basically executed the AWS Lambda Layer command, and we are in our normal host machine, that is home EC2 user layer, right? Now here let me clear this, and if I execute docker container ls, here you will see that currently we are having one active container which is related to this public ECR AWS SAM build Python 3.12 image, right? And their bin bash command is getting executed. Now all I will do, that here our zip file got created, we have created the Lambda layer, so this particular container no longer needed. So all I will do, I will just exit this particular container. Okay, so here you can see we came to our layer folder which is basically available within our host machine. Now I will execute that same command, docker container ls, and here you will see that the container also got deleted automatically. It is not like we need to execute docker container rm and then provide the container ID. And why this is happening? This is happening because of this -rm command. So -rm command basically delete the docker container from the docker environment once the execution is complete. So here we have basically opened a interactive shell terminal using bin bash and -it to execute these two commands. So that job is done, layer got created, now we no longer need that container, so just we can exit this shell automatically because of this -rm, the container is deleted from our environment. So using -rm, we can keep our Docker working environment very much clean. Once the container job is done, you can delete it. And now we are going to explore how we can do all these steps in a single line. So here if you see, first we have opened an interactive shell, then we executed pip install command, then we zipped all of them. So this is a 3-step process. Can we reduce all these 3 steps into a single line? That we are going to explore in our next section. Okay, stay tuned. So now we are going to explore how we can do this complete Lambda layer build process up to zipping in one single line. Okay, so for that, here I am going to create a fresh directory. So here currently I was in my root and mkdir layer 1 I have created. Earlier the directory in which we are working was mkdir layer. Now it is layer 1, and I'll be going to that particular directory. Okay, and then here I'll be creating the requirements.txt, which will be having the same Python modules whatever we have installed in our earlier section. And now here this is the one-liner command. So earlier what we were doing, docker run we were executing because here we were running this particular image and we were creating the container. -rm we were executing to delete the container once the execution is done. -it bin bash was required to get the interactive shell. Okay, and this is used for volume mounting. This was used for defining the working directory, and this was used for defining the image on top of which we were launching the container, right? So here the command is almost same. If you see docker run -rm just to delete the container once the job is done. We are doing the volume mounting, but we no longer need this interactive shell now. So I am not keeping -it and bin bash. Instead of that, here what we are doing, we are keeping that app folder working directory definition. We are keeping our base image as it is, but we are only keeping bin bash. Earlier we were keeping -it/bin bash, that was helping us in opening or getting the interactive cell. But this time I don't want interactive cell, I just want to execute two commands, one is pip install, another one is zipping. So that I am putting bin bash -c. So that way these commands it will be executing in bash mode and the result it will be returned. Okay, so -c. So the two commands we were executing, one is pip install this, one is zip. That same thing I have written pip install -r requirements.txt, and the target directory here we followed that same pattern in which Python 3.12 Lambda Layer expect. And then once this pip install command is done, we need to zip, right? So I want to execute two cell command, so I have given ampersand, as simple as that. So we can execute this particular command, and suppose you need to create the Lambda layer for Python 3.8 in one single liner. So you need to change two places. One is the base image what you are pulling, that should be Python 3.8, so that within the container the Python should be 3.8, so that if we install some Python dependencies for our Lambda Python 3.8 runtime, it will not have any Python version mismatch issue, right? And here if you are changing to Python 3.8, this version also you have to change to Python 3.8, because this format is expected for Lambda layer. Okay, anyway, I am not interested in Python 3.8, I just want to show you Python 3.12 demo. So here what I will do, I'll basically execute this particular command. So it will pull the image, it will do pip install, and then it will zip the file. All these things it will do together. Okay. So here you can see it is installing, and then here in another terminal, let me go to the layer 1 directory, cd layer 1, and here if I do ls, here you can see that requirements.txt was anyway there, and Python within that lib, within that Python 3.12, like that folder structure, the pip install happened, and soon we will be able to see the zip file also got created. So here you can see the zip file execution is done. So these are basically our zip command output, because in this cell only we executed that docker run command, right? So here if I go to the another cell and if I execute ls, here you will see lambda layer.zip got created, right? Now to register it, so here I can give the layer name as one liner, okay, and the file name based on which layer will be created is lambda layer1.zip, because that's what the zip file name here we have given, and then here I will run it. Okay, due to the volume mounting here in layer 1 also, as you can see from the container, this particular zip file you can access here as well, and this is happening due to volume mounting. Only difference is in our earlier section we created this particular installation and zip in two lines, but this time in a single line we have done that. So here you can see that the lambda layer got registered, and we can test it as well. So here if I refresh our lambda in US East 1 region, so here you can see one liner, this particular layer is appeared. Now I will go to my same lambda function, I will delete the older layer and I will add a new layer. Just now what we have created using one liner. Okay, so here I will choose the version is 1, I'll add it, and then I'll click on test and test it out. So here if you see, the execution is successful. That means using one liner command also, whatever lambda layer we have created, that is perfectly working, right? And I hope this is pretty much understandable. This way, using the post volume mounting concept in Docker image or container, we can streamline the process of lambda layer creation. So it's all for this particular section. We will catch you up in the next section. Thank you. So in our previous section, we explored how using these two simple commands we can create a lambda layer for any compatible version if we have Docker and AWS CLI installed in our host machine, right? If you want to create lambda layer for Python 3.8, then just we need to change this particular location and this particular location. These two places are basically deciding for which Python version the lambda layer will be created. So these two locations we need to change. Now in our host machine, at least this Docker and AWS CLI should be available. That way we can easily create the lambda layer using these two commands. But let us simplify this whole process further, how we can directly create the lambda layer from the GitHub itself. Okay, so that time we can take help of GitHub action. So the automation process for lambda layer build using GitHub action is explained here. So let me explain you the algorithm first and then I will explain what code we have written. So in our previous section, we have explored that to create the Lambda layer using that one-liner Docker command, what we need to have, we should be having a host machine where we should be having the requirements.txt file available. Okay, and here we are launching a Docker container, and this particular container working directory we are mounting with host volume directory where this requirements.txt file is available. The container is reading this particular requirements.txt. It is pulling that particular Docker image what we are mentioning, and then it is doing pip install based on this particular requirements.txt. It is basically creating that zip file in that same working directory within container, and because that particular container working directory and host current directory are mounted, what is happening, that zip file is also available in the host machine current working directory, and from this particular host machine we can access this particular file and execute a AWS Lambda publish layer command to publish a new version for our Lambda layer. Okay, now let's see how we can do the same operation using GitHub action. So for GitHub action, we should be having a host machine first of all, where Docker and AWS CLI both things will be installed, because to create the zip file we need this Docker command, so that time Docker is needed, and to publish the new Lambda layer we need to execute AWS Lambda publish layer version, so that time AWS CLI needed. So we need a host machine in GitHub action runner where both of these are available, and that, for example, we can choose Ubuntu latest where both of these are available, right? That problem is solved. Now let's consider, as I told you, that within host we should be having requirements.txt which the Docker will consume to do pip install. Okay, so here our GitHub codebase is available, right? Within GitHub codebase, within a particular folder, maybe let's consider the folder name is AWS. Within that, here I can give like this way, Lambda Layer _ build. This is one particular folder within AWS folder, and within that we can put our requirements.txt file. Multiple requirements.txt file can be available. For example, for pandas installation, we have one requirements.txt which is pandas.txt. Okay, within this particular requirement file, we have just written pandas. So that way, if we do pip install -r pandas.txt, that way pandas will be installed at least. I hope you are getting this. So in our GitHub, in this particular structure, we'll be putting as many different layers we want to create for different Python modules. Those many requirements.txt file with different name we'll be putting in this kind of folder structure. Pandas.txt. We might have request.txt where request module will be available, right? So just we need to mention that particular text file in the pip install command dynamically. Perfect. I hope you got up to this. So as a first step, what we'll do in our GitHub action workflow, that first we'll do git pull within our host machine where the GitHub action is running, right? So that is git checkout we'll be doing as part of the first step. That's what is done here. As soon as we'll do checkout in this host machine, that is in the backend machine where the GitHub action is running, there this kind of file in that runtime will be available, like AWS Lambda Layer Build and pandas.txt. Okay, so here in this particular host machine it is available. So what we will do, just to make everything isolated, if you want to create multiple Lambda layer, one particular layer will not impact other layer. So just to have a safeguard on that particular section, we will not mount the current working directory where git checkout happened, basically where this particular folder structure and files are available from our git. That volume directory we will not mount with our Docker container. Rather, just to separate each Lambda layer creation, here what I will do, I will create a temporary directory somewhere else. And from this particular location, the requirements.txt file I will be copying in this particular temporary directory. And this particular temporary directory will be mounting with the Docker container. And then we will do a pip install and zip file command will be executing. So that way we will be getting the zip, and because volume mount is done, so in this particular temporary directory, this zip file will also be available. And this temporary directory is basically within our host. So we will basically authenticate our host with AWS, which is having AWS publish layer policy. And that way, once this zip file is available in this temporary directory, from here we can easily execute AWS Lambda publish layer command to update a new Lambda layer. So that's what we are doing here in this step. So first step is checkout. to get this particular requirements.txt file within our host machine. Then as part of the next step, we are authenticating this particular host machine with AWS with access key, secret key and region. Then as part of the next step, we are creating the Lambda layer. And this is a common code. There are 4 things which can take dynamic value that we can configure as environmental variable. So each time you may need to change these values. That's it. What are the variables we need to configure? One is runtime. That is here. Let's consider sometime you might be interested to create a Lambda layer for Python 3.8, 3.12, 3.11 and so on. So that time you just put your runtime here. Okay. Then requirements file. You need to provide the complete path of the requirements file based on which you want to do pip install and create the Lambda layer. Okay. So here as I told you that this is our pandas.txt file where pandas is mentioned. So that way for pandas we can create the Lambda layer. So that requirements file absolute path will mention. Then the layer name. What our Lambda layer name should be having and description. Okay. So here Python layer for pandas and numpy, like that way we can mention. So that when it will show in AWS console, we can easily understand from this description that what are the packages installed in this layer. Okay. Now as part of the first step here in the run command, what shell script we are executing? First we are creating this temporary directory using mktemp command, and the folder name will be like this, temp-dir-6 random characters. Then here we are echoing just to show you the logs that the temporary directory is created. Now here what we need to do in this temporary directory, we need to copy our requirements.txt, that is here in pandas.txt. So that's why we are executing cp $requirements.txt, then $output folder requirements.txt. So here what we are doing, requirements file. So this is having this absolute file path of our requirements.txt file, right? So that absolute file name here we are mentioning, and that file we are copying within output folder. Output folder basically our this particular temporary directory. There we are creating a file called requirements.txt. There we are copying the content. Okay, and this echo first we have done, that is we are executing this command and then we executed this command. Then this is the zip file command what we need to execute. We are pulling the Docker image. Now see, the Docker image pool is also dynamic. Here we are mentioning $runtime $latest. So here whatever runtime you will be mentioning, if you are mentioning Python 3.12, then the Docker image will be pulled for Python 3.12. If you are mentioning Python 3.11, then this Docker runtime will be Python 3.11, like that. Okay. And here we are echoing that the Docker base image to be used is Docker image, like that. So each line we are executing some command and we are echoing also just to get the logs also. Then the volume mounting command we are executing, that -v, we are defining our output folder, that is temporary directory, we are mounting with layer directory. So this layer directory will be our containers working directory. Okay. So that is basically host volume mounting we are doing. And that's what here we are printing, that volume parameter to be used, this volume parameter. Then package folder. Package folder is what our Lambda layer structure we should follow, that is Python lib. And then if we are creating the layer for Python 3.12, then Python 3.12 should come. If we are creating the Lambda layer for Python 3.8, then 3.8 should come. So here we can dynamically take this runtime value from this particular environmental variable, right? So that we have taken here and then cited this. Then here echo pip install will happen at this particular folder that we are printing. Then install command, pip install -r requirements.txt -t target directory or package folder. And then we are basically executing this one-liner Docker command, docker run -rm, volume mounting we are doing. We are defining current working directory as /layer, and that layer directory only we have mounted with our temporary directory what we have created in our host machine. Then the base image we are pulling dynamically, and bin bash -c. First we are executing pip install, then we are zipping it up. So once this command will be executed, the zip file will be available in this temporary working directory, and the Docker container also will be automatically deleted because here we are executing rm command. So that way Docker's job is done. Now we have the zip file. All we can do, we can execute this AWS Lambda public layer version with the dynamic layer name, compatible runtime, and this zip file, whatever we are having in our temporary directory in our host machine. So that way, using this particular set of shell script, we can easily build a Lambda layer dynamically from the GitHub action itself. So without any further delay, let us directly jump into the implementation section now. So here what I will do, I will go to my GitHub repository, and here I'll be creating a new repository. And the repository name I can give Docker Layer Creation YT Demo. Okay. the repository I can keep private, and I'll create this repository. Now here I will create a new file. So obviously we should be having at least requirements.txt, and this is the structure I can follow. You can follow any structure. Whatever structure you follow, please make sure in this requirements file you provide the complete path of that file. Okay. So within AWS we'll be having this Lambda Layer Builder, and within that we'll be creating our requirements file. Okay. So here we are creating the requirements file only for pandas. So I'll commit these changes. So that is created. Now here we can create this complete GitHub action. So here I'll click on add file, create new file, name. Here obviously we should be going to root level, and then here I should add the file, because here GitHub runner should be following this structure like .github /workflows then /main.yml, and here I can paste this code. Okay, all we need to do, AWS access and secret we need to provide. So for that I will go to AWS management consoles, I'll go to security credentials, and I'll be creating a security credential. As of now I am creating root level, but if you are working in production system, then you can tune with proper restricted policy. Okay, so here I'll click on create access key. I understand, create access key. So access key is created. I'll paste that here. Secret key also I'll paste that here. Okay, AWS region US East 1, that is fine. And here no need to change this code. So you can use this whole part as constant. Okay, this is a framework kind of thing you can consider. All you need to do if you want to create a Lambda layer, you need to play with these 4 variables. Just change accordingly. So here I can give this layer name as Docker layer from GitHub and _yt. So here I will commit these changes. As soon as I will commit, what will happen, that because here we have basically given on push, that means automatically one workflow will be triggered. So I can open actions in a new tab, and here you can see that the workflow is triggered, and you can go inside that and parallelly open here the Lambda console. And here I can open layers, and here as of now our layer creation is going on. So let's wait for some time. Here you can see the zip file creation is going on now. If you go completely top of this particular logs, here you will see every step it will be basically printing, because here we have given multiple echo commands in each line, right? So you can explore these steps as well. And the central idea is just like what we discussed earlier, that is post volume mounting. So here if you see, first it has created the temporary directory, and here within /temp -dir some 6 random characters it has created, and this is happening because of this particular line mktemp command. Okay, then next what we are doing, we are basically executing this particular thing from our GitHub post. We are copying the pandas.txt in requirements.txt within our temporary directory. Then here docker base image to be used is this one. Volume mounting command is this one. That is our temporary directory. We are mounting with the layer directory, which is current working directory for our container. Then pip install will happen in this particular location, right? Then this command it is basically executing. Once the execution is done, here if I scroll completely below, the logs will be very big. Here you will see that the Lambda layer will be registered, and layer name is this thing. Let's see. I'll just refresh, and here if I just do a command def, here you will see that this particular layer got registered. So here you can see in the description beautifully it is showing Python layer for pandas and numpy, and this is coming because of this particular thing, this description. Okay, so I hope you are getting this. Now here what I'll do, let me basically create a function and let me show you it is properly working. So here function name demo docker from GitHub, And here runtime we will be choosing Python 3.12 because we have created the layer for Python 3.12 only, right? So create the function, and here I will execute import pandas as id, okay, then import numpy as n. You might be asking that numpy we have not installed, right? But when pandas is installed, by default numpy also get installed, okay? So let the function get updated. So here it got updated. If I directly test it out without patching the layer, here it will throw error that no module name pandas. So let me add the layer. I'll click on add layer and custom layer. So Docker layer from GitHub YT, this is the layer what we have created, and I'll add it. Simple. Okay. So here the layer is added. Now I can test it out, and here you will see this time it will not throw any error. It is successful, right? And let me show you the Lambda layer creation for another package. For example, within this particular folder, here I can have add file, create new file, request.txt. Okay, so for request module, suppose we want to create the Lambda layer. So here I can write requests. Okay, and I'll comment these changes. So now here what I will do, here in this particular YAML code, I need to update among these 4 variables. So runtime be Python 3.12, not a problem. Now this time I want to create the requirement file for request.txt, not the pandas one. So we're taking that, I'll update that here, and here layer name I can provide Docker Lambda Layer from GitHub YT request. Okay, and here Python layer for request module, right? And here I can commit this particular thing, but I guess one particular GitHub action will be starting because the request module we have created, right, that particular requirement file. So due to which this got triggered. So you can ignore this. Basically this will again register one layer version for this Docker layer from GitHub YT Lambda layer. Okay, we can ignore that particular run, and I'll commit these changes. Okay, so because of this particular commit, what will happen? One request module layer will also be created. So let's refresh this, and here you can see our main.yaml is started. Okay, and within the same workflow, you can have multiple layer creation command. Those all will be isolated with each other because every time we are creating temporary directory, and within that we are doing mounting and installation everything. Okay, and once each step is executed, we are deleting that output folder also. So no worries on whether one layer creation will impact other layer creation or not. No need to worry on that. So here you can see that, okay, here update Lambda layer for pandas. I think the name I forgot to update. That is fine, not a big deal. Here this name also you can update Lambda layer for request module, like that way you can put. So that way requirements.txt, here it is installing for request module, and with this layer name one particular layer will be created here. I can go to layers and I can refresh the screen, and here you can see one layer got created, Docker layer from GitHub YT request, right? Just now it got created, and here description, if you check, Python layer for request module. You no need to change anything, just put the description and the requirements file and layer name properly. And if you are interested in creating Lambda layer for some other Python version, just change the runtime use. Okay, now let's see whether this request layer is properly working or not. I will update the code. First I will import the request module. Import requests. And here we can test it out, and it will fail because request module is not defined. I'll just add our latest created request module layer from here. I'll add it, and here the function is getting updated. Once it is done, we can test it out, and here you can see this time the Lambda function is successful. So I hope you understood this particular generic framework to build Lambda Layer for any Python version, for any Python packages, right? This is all for this video. For all the sections, whatever code we have executed, all those codes I'll be providing in the description box so that you can play with that and experiment it and understand in a better way. If you have any doubt in any section of this video, just put the timestamp and your doubt in the comment section. I will try to reply back ASAP. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.